Hey, I'm Alex and I'm here to talk to you about your data stack. Imagine, you're building the next billion-dollar app. Uber for kittens. So you have your user data like profiles and locations and kitten preferences probably stored in a database. You have your kitten data stored in another database. You have your payment data through your financial provider like Stripe. You have your website tracking data through, say, Google Analytics. You have maybe customer survey data coming into some sort of spreadsheet. You have email campaign data, social media data, location data, a napkin with your quarterly goals. There are a lot of tools that go into building a product. But at some point, you will ask, well, how's my company doing? Well, you can go into your users database, write some SQL, and see how many users you have. You can go into your Stripe dashboard and see what's your current revenue. You can go into your analytics dashboard and see what's the click-through rate. You can analyze your survey right in the spreadsheet. But what you really want is to understand this data in context, like do users who visit our website leave better survey responses and bring us more revenue? So how do you get from dozens of different tools to a nice dashboard that shows, say, revenue growth by customer segment? That's what the data stack accomplishes. We usually talk about the data stack in terms of layers, but keep in mind that the boundary between layers can be a little hazy, especially as tools continue to evolve. But you'll always have your sources layer, and you'll have your target layer, usually some kind of business intelligence, BI tool, or analytics. Some place where you can create metrics and build dashboards to track performance. One thing you will always need in your data stack is storage. So you have data coming from dozens of different operational tools, and you want to look at all of it at once, so you need to put it all in one place. What that place might be depends entirely on your use case. For example, you might have a single database backing your users and kittens and transactions, and then you might as well put the payment data and the survey data into the same database. And that might be enough, at least until your kitten app really takes off, which it will. And then you might want to separate your storage from your operations, and you might have heard terms like data warehouse, data lake, data lakehouse. These are really just different approaches to building this storage layer. Let's put a pin in this for now. We'll come back later. Ultimately, you have a place to put all your operational data. But how does this data actually make it there? One way is through APIs. All of these tools will have API endpoints exposed so that you can write a script, hit the endpoint, extract the data, and put it into storage. As you might imagine, the more tools you have, the more complicated this gets. You might have to keep track of dozens of different APIs, learn them, stay up to date, troubleshoot them. A lot of work. So there are tools that can do this for you. Ingestion tools like Fivetran or Airbyte or Stitch have pre-built connectors that can connect to dozens of different data sources and can put data into dozens of different storage engines. Often you'll use a combination of pre-built tools for standard sources and APIs for sources that you build directly for your product. So once this data makes its way into the storage, you can start building dashboards, right? Not so fast. Think about what this data looks like. You have your payment data that's separate from your user data. You have like a millisecond level logs from your website tracking, but you also have, PDFs of screenshots. You have pictures, you have text, you have JSON data, you have CSV data, a lot of different data in different places and different formats. For analytics, you want your data in nice tabular format so you could ask questions, how many customers did I have last quarter? To get the data from unstructured to structured form, you need to transform it. This is the haziest layer, also the most difficult one, because usually you'll have multiple tools working in concert across your entire data stack to transform your data. For example, you might write a script that transforms some data in real time, but some ingestion tools like Fivetran also have some transformation capabilities, so you might start transforming your data as you're ingesting it. Some BI tools have limited modeling capabilities. For example, have you heard of Metabase? So you can build your customer model and subscription model in the same tool that you use to visualize them. There are also dedicated transformation tools like dbt or Dataform, and there are also data stores that have transformation capabilities like Databricks. You might have heard terms like ELT, ETL, ELTL. ETL stands for Extract, Transform, Load. ELT is Extract, Load, Transform, and all of these are ultimately about when and where this transformation happens. This is also where the difference between data warehouse and data lake comes into play. So data warehouse is where your nice structured data lives. And data lake is where your unstructured data is stored, should you choose to store it. So ETL, Extract, Transform, Load, assumes that you only have a data warehouse. So it extracts all the data into a temporary staging area where it's transformed and then loaded into the data warehouse. So the only data that's stored in the data warehouse is the clean tabular data. ELT, Extract, Load, Transform, assumes you have a data lake, so it ingests all the data into a data lake, which is now part of permanent storage. And then there are tools that can connect directly to the data lake and read the unstructured data, like a lot of machine learning tools. Or you can take this unstructured data in the data lake and transform it and load it into a data warehouse. In the old days, when storage was expensive, people only stored the data that they know they need. So only the clean, structured data in the data warehouse. Nowadays, storage is cheap and we have different workflows too, and who knows when we might need this raw unstructured data. So often people will have both a data lake storing unstructured data and a data warehouse storing structured data, both in the same data stack. So data warehouse and data lake are really concepts rather than specific tools, but on a software level, the data warehouse is usually a database that's optimized for handling large amounts of data quickly, and data lake can be something like object storage in the cloud, like AWS S3 or Google Cloud Storage. Once you have your data in the data warehouse, you can usually directly connect your BI or analytics tool, so it could read some tables, write some queries, and build you a dashboard. One last thing about this pipeline is, how do we actually handle this data flow? For example, if a change happens in my user's database, does it immediately in real time propagate to my BI tool? Or maybe I have a daily job that extracts all the new data and updated data, loads it into my data warehouse, and makes it available for the BI tool. Or maybe I load into the data lake in real time and transform the data once a day because it's a resource-intensive process. What happens if one part of this pipeline fails? What are the downstream dependencies? This is handled by the orchestration layer. You can write some scripts that control this entire data flow, but there are also tools like Airflow or Prefect that will do this for you. You separate every part of the pipeline into small individual tasks and put them into what's called a DAG, direct like acyclic graph, that encodes the dependencies between tasks. You define schedules and failure rules and let the orchestration tool to do the job. These are the main components of the data stack. As your data needs evolve, you might find yourself needing other things like, for example, maybe you want to take this nice structured customer data and put it into your customer management tool like Salesforce. That's reverse ETL because you're extracting from the data warehouse and loading into a tool. Or you might want to have automated tests at each stage of the pipeline or monitor the flow of your data, so you introduce a overarching data quality layer with tools like Soto or Great Expectations. Data landscape is vast and exciting and constantly evolving. I hope this video helps you understand a little bit better of the different components of the data stack. Check out the links in the description to learn more, and thanks for watching.